Hi everyone, so today I'm going to be going over some geometry review. So you learned this in geometry, but you may need this for any standardized test, specifically the SAT. So let's talk about a circle for a second. If I have a circle, I need to know that if there is like a nice dot in the center of that circle, okay, maybe like that, that's the center, okay? And from the center, I can draw a line to the circle called a radius. Now, in the front of the math section, they are going to give you a few formulas for radius that are going to be, or for circles that are going to become important. The first one's going to be the circumference of a circle. Okay, so circumference is like the perimeter of a circle, and the formula equation is 2 pi r. So 2 times pi times radius. And that's going to cover like all the outside of the circle. Again, it's like the perimeter of a circle. That's the circumference. And then they're going to give you the area of a circle. Again, relates to radius, but that formula is pi r squared. And remember, area is like everything inside of it. Everything inside the circle. But we do need to understand that radiuses are all congruent in a circle. So I can actually draw in two radiuses and they would be equal. And if I connect them at their base like that, you might see that I'm creating an isosceles triangle. So that's something that could come up that's important for you. But we're going to go over some theorems that I have found are helpful in case you encounter a circle problem. So the first one's the radius to tangent theorem. So back in geometry, you learned and probably proved it that if you have a tangent line, so a tangent is a line that touches a circle in one point on the outside of the circle called the point of tangency. If you connect a radius to that tangent at the point of tangency, it creates a right angle. So we say that the tangent line is perpendicular to the radius at the point of tangency. Well, how could we use something like that? Well, I could give you a question like this, and I tell you that this is 60 degrees, and I draw these two tangents to the circle, and I actually ask you, and I connect my radiuses there, and I ask you to find this angle x, okay? Well, the first thing that I might do there is notice that I've got a radius drawn to a tangent, so this is a right angle, and this is a right angle. And now I know we got circles going on, but now we also have a quadrilateral. And the four angles of a quadrilateral add to 360. So I can add 90 plus 90 plus 60. So 180 plus 60 gives me 240. And then I can subtract that from 360 and get 120. So this angle right here would be 120 degrees. All right, speaking of that angle, you learned that that angle has a special name. An angle whose vertex is the center of the circle is called a central angle. And that central angle has a relationship with the arc here. This is an arc of a circle. It's a part of the circle. Now, arcs can be minor or major arcs. You learned that in geometry. But what you really have to know is that arcs can have measure, so that's degrees, and think of it like the rotation of the circle, and they can also have length, which would be a part of the circumference. So they can have rotational degrees, and they can also have length. All right. So in geometry, you learned that the central angle, its rotation, its degrees is actually the same as the arc. So you can see that arc AB, the measure of arc AB, that's how I would write that. The measure, that little m means the measure of arc AB. You can see I'm using an arc symbol above it. The measure of arc AB is 60. So then the measure of angle AQB is then also 60. So the measure of an arc is equal to that of its central angle. All right, after central angles, you went on to another special type of angle called an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. So you can see angle B is an inscribed angle. Its vertex lies right on the circle. And its relationship with the arc is that it's half the arc's measure. So if I tell you that the arc is 20 degrees, then this inscribed angle would be 10 degrees, okay? And that's the inscribed angle theorem. Those angle relationships are going to probably come up at some point for you, and they're very helpful to know. All right, the last thing I'm going to talk about today relates to those angles and to arc length and area of sectors. So first of all, we talked about that arc, okay? And I said that it had measure. Well, measure is degrees, but it also has length. Arc length, I want you to think of it as a proportional relationship. A proportional relationship between the central angle and the whole circle and the arc length and the whole circumference. There were lots of ways and formulas you learned to do this, but I like to think of it as a part to whole relationship. Part to whole would have to be equal to part to whole. All right, well, let's think about it. What part would relate to the angle? So this angle, we're going to call it x. That is the part of the circle. The whole relates to the other angle relationship in the circle. Well, the whole angle would go all the way around and would be 360 degrees. Okay? All right, then that relationship, that has a relationship with the arc length. The arc length would be this red piece right here. Okay, that's the arc length. And the whole arc would be the entire circle, the length of the entire circle, which we called the circumference. Okay, so part to whole, central angle over 360 is equal to the arc length over the circumference. So again, x over 360 equals arc length, I'm going to call that s, over 2 pi r. Now, it's a formula, but if you think about it as a part to whole relationship, it won't be so hard for you to remember. All right, now let's look at it as the area. The relationship, the proportional relationship, is exactly the same as the arc length relationship. Well, that's good. I don't have to remember too many things. But that area of that sector, so the area of the sector is like the piece of pizza. It's like this whole section of the circle. And again, it's a part to whole relationship. X being the central angle over the whole circle's rotation, so 360 is equal to the area of the sector, so that piece of pizza, over the whole area of the circle, which would be pi r squared. All right, so I know that was a lot of information. You've been exposed and learned this information before. These relationships could possibly come up for you on the SAT. So what I want you to do is maybe rewatch it if you have to, maybe take some good notes if you need to. And I want you to pay close attention when you see circle problems on your practices. If you can kind of think back to that proportional relationship with this arc length and area of sectors, it might not be so hard for you to understand. All right, guys, that's just one small piece of information on circles for SAT. Hope it was helpful.